Hello and welcome everybody to this presentation about building decentralized supply chains with Zebra data services, distributed ledger, and serialized data. My name is Jose Manuel Cantera. I work for the IOTA Foundation. I'm currently a tech analyst and project lead, and I'm leading different projects related to innovation on global trade and supply chains. Some of these projects are developed together with Zebra Technologies, as I will explain. First of all, we need to understand what does it mean to build decentralized and transparent supply chains. This revolves around different problems that the industry and the digitalization of modern supply chains are coming out. These problems have to do with the provenance of the goods, with the proofs of origin, with the ethical sourcing, with the visibility, with the transparency, and etc. But nowadays, there are many barriers to build really these applications. Why? Because there are not live or fully trusted data and interoperable formats available. But also there are other missing pieces. So we lack physical to digital link mechanisms. We lack mechanisms for data authenticity, for data immutability, for having a full traceability from the source, enabling data accountability. And we also lack proper data decentralization mechanisms and technologies. Nowadays, there are a lot of silos which can make some of the actors to have some power abuse. And of course, data interoperability is another key point, because if we have data interoperability, we can avoid vendor locking. And what is blockchain and how it can help to tackle these problems in the supply chain? Well, in general, we are very used to centralized ledger. So the typical example of a centralized ledger is a bank. A bank is like a clearinghouse of transactions issued by different parties, and the trust is given to the bank, for instance. So all the participants give trust to the central authority, which is in charge of consolidating the view of the ledger and consolidating a single source of truth. But there is the approach proposed by blockchain, in which there is no longer any central entity, there is no longer any central authority, and the source of truth is distributed among the different participants, that they interchange transactions between them, and they must agree on a common truth, on a common consensus. And this is a problem that has been solved by blockchain, because with blockchain, you build blocks of information that are cryptographically linked and agreed between the different stakeholders. And that's the single source of truth, which is no longer centralized. It's decentralized among the different participants in the network. So, but as a result, the origin of blockchain is for transacting value, but it's evolving to also transacting data. And as a result, you can build a network of trust between different stakeholders where they agree on the view of the ledger, on the view of the world, so that this is trustable between the different participants. And how it works, blockchain, is that different incoming transactions, they can be value transactions, they can be data transactions, arrive into the network, but these transactions in the end have to be put into blocks, and those blocks have to be validated, and has to be validated by the special kind of nodes, which are the miners. And these miners must be in a serialized way all these blocks and link them cryptographically one by one after the other. And this is a process that takes a lot of time, takes a lot of energy, but it's like a bottleneck. So in the end, the number of validated transactions or confirmed transactions per second you can get on a typical blockchain network is very limited. And on the other hand, you have the fees. So the fees can be very high. And for certain transactions, for instance, data transactions in the supply chain, those fees can be very costly in the end. So new innovations have happened in the world of blockchain, and we are moving from blockchain to distributed ledgers. And one of the reference distributed ledger currently in the industry is IOTA. So IOTA has a different approach than blockchain for reaching consensus on transactions. So instead of relying on miners, what you really have is that each participant in the network is approving transaction, is validated transactions from other participants in the network in a way that in order to issue a new transaction to the network, you first need as a participant to approve 2 or more transactions from other participants. And this approval is done by building a directed acyclic graph in which these transactions are interlinked. And the beauty of this model is that consensus can be reached, but without any kind of transaction fee, because the network becomes collaborative and no longer there are miners or specialized nodes in charge of doing this. No fees and more scalability, because no longer we have the bottleneck of building the blocks. Just everything happens in parallel because we are building on the fly this directed acyclic graph. And this is IOTA. And this directed acyclic graph is called the tangle due to the shape that it has. So IOTA is offering what other blockchains are offering. So we are permissionless. You have security, of course, because we are based on cryptography, state-of-the-art cryptography. You have immutable data. We are decentralized and we are open source. All the technology is available and documented for being used by developers. On top of that, we are more scalable due to the nature of the tangle, and you can reach, for instance, 1,000 transactions per second. We are more energy efficient due how the consensus is built. We are feeless. We don't have any miners. We have parallel architecture, but also, if you wish, you can build your own tangle networks that could even be anchored to the mainnet tangle network. So it's a very flexible distributed ledger. Not only that, it's offered by IOTA. On top of the basic protocol, different frameworks have been built or are being built that allow applications to manage higher level abstractions. And the 2 frameworks that we will focus on this presentation will be the digital identity framework, in which identities of organizations, devices, and even people can be registered, can be used to build a network of trust in a self-sovereign approach. And we have streams. Streams is a cryptographic protocol built on top of the tangle that allows to build channels of organized information around tangle transactions in a way that you can easily build sequences of data around items. And all of these frameworks are built on top of the core IOTA protocol. Well, IOTA is a very active and growing ecosystem and is being led by the IOTA Foundation. We have collaborations and partnerships with reference industry corporates like Zebra Technologies, Dell Technologies, but also with new actors like everything non-for-profit, other non-for-profit foundations, or the academia. So it's a very complete and a very, I would say, diverse ecosystem, the IOTA ecosystem. This ecosystem is being led by the IOTA Foundation, which is a non-for-profit founded in Germany in 2017, and now with more than 150 employees distributed across the world. And you can see there the numbers of our thriving community. And it is important that some of these patents or peer-reviewed research papers have been developed around the world by our community. So it's not only the IOTA Foundation who is involved in this ecosystem. And following up with this very active and very, I would say, revolutionary approach, we are starting being recognized by the European Commission as one of the potential distributed ledger technologies to be used in building a next generation of European blockchain services infrastructure. We are one of the first 7 projects selected. Very soon there will be only 4 of them. And we have been selected because we have all the pillars to build a really scalable, energy efficient, and secure European blockchain services initiative. And you can imagine this public infrastructure, the impact may have in supply chains. For instance, for meeting all the compliance and regulatory processes that are coming in different sectors like industry or food, or even in customs. So you can see that the potential of IOTA technologies. So we have so far explained the first pillar of our talk, but now we need to talk about which is distributed layer technologies. And now we have to talk about the second pillar of our talk, which is data serialization. Data serialization is a very important aspect in terms of interoperability. So even though we could build decentralized supply chains using a distributed layer like IOTA, but if we don't have a common data serialization format, if we don't have this interoperability, if we don't have this common language, that could be very difficult in the end, because we will restrict the applications only to a few stakeholders, and we will end up in another vendor lock-in and probably in another data silo. And this is what we want to avoid. Fortunately, the industry is recognizing the need for a common universal web language for supply chain events. And this is what GS1 has been working for the last 4 years in updating the EPCIS standard with a new version, which is the 2.0 version, which allows to record the what, when, where, why, and how of the different business steps that are being done in supply chains. But this time using modern technologies. This time we are using JSON and JSON linked data to model these different events. And we are using REST APIs in order to allow applications to make use of this data serialization format. All of this with well-defined semantics. So you can see different here in this slide, different business steps like manufacturing, packing, shipping, or selling. And this is how EPCIS 2.0 would allow to capture these different data dimensions. And now the standard also allows to capture conditions reported by sensors. So if there is an application or some item in the supply chain that needs to be, for instance, transported under particular temperature conditions, the standard allows you to record those conditions and those events, and later allows the different stakeholders to verify that the goods were transported using under the proper and proper agreed or regulatory conditions. So this is very important, and the standard is generic enough so that it can be used in different scenarios and in different setups, in B2B applications, B2C, and even business to government interactions. So it's very generic, very complete, and very extensible. So for instance, if a particular domain of application, for instance, the automotive domain, needs to create their own language, their own sublanguage, their own vocabulary on top of EPCIS 2.0, it can be done. And for instance, the VDA, which is the German Automotive Association, has created some vocabularies that can work with EPCIS 2.0. So data serialization formats, but of course, for creating applications, you not only need data serialization format, but you need as well APIs. And we in the IOTA Foundation, together with Zebra Technologies, we have been working on different APIs. We call them track and trace ledger APIs. They are REST APIs that you can see a summary of them in Open API format in this slide, where allow us to capture device events coming from RFID readers, from barcode scanners, from Zebra printers, but also business events, GS1 EPCIS 2.0 business events, and automatically record them on the IOTA distributed ledger. And later, any participant in the supply chain, any stakeholder can query them, can get access to them, and even can verify their authenticity. And for doing that, it is important to use IOTA identity. IOTA identity is the framework, as I said before, that allows to identify and verify the different participants in the supply chains. And moreover, these participants in the supply chain can verify other participants through the identities and public key materials recorded on the IOTA distributed ledger. So a network of trust can be built without relying on a central public key infrastructure or on a central certification authority. So that's how the track and trace ledger APIs work, and I will be showing two different use cases where these APIs can be used together with the IOTA ledger, together with Zebra RFID or Zebra data services, and of course EPCIS 2.0 to solve different use cases that I will be showing. So if we go to the next slide, the first use case is for the automotive supply chain. The automotive supply chain is a very complex supply chain because it involves not only the final manufacturer, the OEM, but also suppliers at different tiers. So the OEM has level 1 or tier 1 suppliers that provide the parts that have to be assembled at the OEM factory, but each of these parts supplied by a supplier have different components that are provided by other suppliers. So in the end, you have a tier N supply chain. And this is very complex to be managed. And what is happening nowadays is that if a faulty component is found by one supplier in the supply chain, and that has an effect on a final car, it's very difficult to track and very time consuming to find which cars are affected by that faulty component. So this is why different organizations like MOBI have been working on fixing these problems and trying to define a new way of managing these supply chains so that these supply chains are more transparent and are more easy to be managed, and also allows to solve these recall problems when they happen, for instance. So essentially, the idea to solve these problems, of course, is to track every component in the supply chain and also the parent-child relationships between these components, and also tracking all the transportation and movement of the goods across countries, across factories, etc. And for doing this, different standards can be used. Can be used the VDA standards, can be used the GS1 EPCIS 2.0 in combination with the VDI standards. And of course, we can use automatic identification and data capture technologies like RFID or barcodes, of course. So this is so we have the pieces, but these pieces have to be combined together with the distributed ledger technologies so that we can achieve this decentralized view and transparent view and track and trace view of the supply chain. Because if we could always build a centralized system for tracking this, but if this is a centralized system, we will give the power to one entity to have all this data, and we don't want. We want to have each entity to have their own view of the data and reach consensus through the usage of the distributed ledger. And we want the different participants to establish trust between them through the identity, through the decentralized identity. And this is how this can be done with Zebra data services and the track and trace ledger APIs. And here you have an architecture in which we have distinguished between different flows that have to do with putting data on the distributed ledger, and flows that have to do with retrieving data from the distributed ledger through the REST APIs that I've mentioned before, through the REST APIs already published on Zebra Savannah. So you have to take into account that these APIs are already available and can be used to build proof of concept, and of course later could be used and could be migrated to production ready use cases. So first of all, we are going to focus on a typical flow where a data capture device like an RFID fixed reader like the 96-100 from Zebra can do a data capture operation. This is going to arrive into the Zebra cloud, and from the Zebra cloud, a webhook already deployed on the Zebra cloud is going to allow to invoke the track and trace ledger APIs. So once this request from the reader and through Zebra Savannah, this is automatically indexed and on a data store, and finally a string channel is built on the distributed ledger. You have to take into account that this indexing process happens per item. Remember that we want to track all the different parts, all the different items individually, because we want to know for each, for instance, final car, what are the parts that were made, were used to build the car. So essentially, the track and trace ledger APIs allows you to track individual items in the supply chain. And for each individual item in the supply chains, you have a string channel. And that string channel is storing all the events that are happening around that part within the supply chain, and the different events that may have been generated by different participants in the supply chains identified by their IOTA identity. That's the important thing. So before sending any data, all devices, all participants in the supply chains will have to be registered and properly verified through the identity part. That is why there is this 0 in this slide. So essentially, the track and trace ledger APIs allows you to build automatically these streams on the IOTA tangle, publish the data to those streams, and then fetch the data from these streams. And what is this data? Essentially events. and they can be device events, so the raw events generating from the devices, or EPCIS events, as we will see later. So there is the flow of writing data to the distributed ledger that other parties can later consume. And how this data can be later consumed by other parties? Because we have the REST APIs, we have the capability of posting the data, but also of getting the data. And these applications can go through the track and trace ledger APIs and query the data. So for instance, if I want to know for a particular part of my car what components are being used, and also what has been the supply chain trade of these components, I can go to my application, and through the item level tracking component of my application and through the track and trace ledger APIs, I can get all this information and have all the traceability around the component I would like to know. And of course, you need to query your index, you need to go to the proper streams on the distributed ledger, on the IOTA tangle, and get this data. And then you can later say, oh, this data was generated by this part in the supply chain. Let's see what is his identity. And you can query the identity, and you can verify through this identity the authenticity of the data. And all of this we have relying on a centralized architecture, because any participant in the supply chain may make use of the track and trace ledger APIs, may make use of their own instance of the APIs. So that is important to understand. We are not talking here about a centralized system. Each participant may deploy their own infrastructure to support these data flows. And this is the beauty of this approach. And finally, there is also always the possibility that if you want to go directly to the distributed ledger and consume this data using the IOTA Strings APIs and IOTA Strings libraries, you can always do this, because the APIs also allows you to map your current supply chain item, the identity of your item, to a strings channel. And then once you know the strings channel and you have the proper keys, you can get access to this data. And it's important to understand that the data can be stored directly on the distributed ledger encrypted, or you could even store on the distributed ledger fingerprint and hashes that later can be verified. So the schema is quite flexible in that sense. And everything depends on the application, on how you want to set up this architecture and these applications. So this is what is happening from an architectural level and from a component level, but from a data flow level, what is happening? Well, what is happening is the following. We have the part supplier factory, where we can have different touch points or encoding points supported by Zebra devices. And whenever a print, whenever a read happens, a device event is generated. And in this case, we are on a business step of storing. So this is when the part is arriving to a particular warehouse. And in this case, we are storing, and this is the corresponding serialization of the business event in EPCIS 2.0 format. And this event, or a fingerprint of the event, can be immutably recorded on the IOTA distributed ledger, and also associated to the identity of the corresponding device, which essentially is backed by the identity of the corresponding participant in the supply chain. But also we can record the RFID data services, for instance, payload that originated that event, so that we can have full traceability from the device towards the business event. And then when this part abandons or leads from the warehouse to the OEM, there is another event. That event that can be generated, for instance, at the door when the transporter is arriving, can also be recorded on the distributed ledger under the same strings channel. So in streams, you are building a chain of events. A chain of events where you can verify the order and the authenticity and source of the event. Not only that, you can record that event, but also the associated business event. And that is very, very important, because we have both the device event and the associated business event. And then, of course, when the part arrives into the OEM's factory, another event will be generated. And the nice thing about this is that these events are properly authenticated on the channel. So essentially, what has been happening can get accessed by the OEMs, and the OEMs can see, oh, this is what happened with this part. This is quite interesting. And not only that, because with the IOTA strings technology, you can even say, I want these events to be seen by these participants in the supply chain, but I don't want these events to be seen by these other participants. And that can also be properly authorized. So this is an example of how we can solve the tire end tracking of parts in the automotive supply chain using Zebra Data Services, EPCIS 2.0, and of course, the IOTA distributed ledger. And here I would like to introduce a second use case. In this case, the main problem is to guarantee the authenticity of some product. In our case, the product we are talking about is wine, is a box of bottles of wine, but in the end, it could be applied to other industries. The only detail here is that we are going to capture, using the same setup, the track and trace ledger APIs, the Zebra Data Services, and the distributed ledger, but using the same assets, I would say, we can build not only the B2B relationships, but also the B2C. So in this case, even the consumer could verify the authenticity of the wine the consumer she is buying. And the idea in general is to be able to detect fraud and also to determine the provenance. And how this could be done, what is the setup? But essentially, we assume that there are three different actors here. We have the winemakers, we have the wine importers, and we have the consumers. And the winemakers want to make it clear to the wine importers, want to assert that their wine is authentic. The wine importers want to verify that this wine is authentic and the provenance is the correct one, and consumers want to verify when they buy something the proper source, the proper origin, that they are not being cheated. And how this can be done? This can be done. We propose one possible approach is that use RFID tags together with the IOTA distributed ledger. So essentially, the idea is whenever the winemaker is commissioning a new box of bottle of wines, can print an RFID label, and this RFID label is going to be recorded on the IOTA distributed ledger. This is the important point. So whenever I print a new label, I record that in the distributed ledger, and not only record what is the identifier associated to the label, but also what is the tag identification data, so that later the wine importer can say, oh yes, this was printed, but also it was printed with this tag. And then that is the key to identify properly any kind of fraud, because even if I get a box of bottle of wines with the same ID, but if the tag identifier is not the same and is not the one that it is being properly recorded on the distributed ledger, then the box of bottle of wine would be considered as not authentic. And the nice thing about this is that these print events can be recorded on the distributed ledger using the track and trace ledger APIs, but also using GS1 EPCIS 2.0 events. And this is what we are showing here, how this could work. So we have of course, we will have the identity set up as it happened with the previous use case that we were mentioned before. And once we have the identities of the different stakeholders, the makers and the importers, you can imagine one maker, which essentially is printing new labels. These labels can be printed through the Zebra services, same file to printer in Savannah, for instance. And once this is printed, a new transaction in the track and trace ledger API will be recorded together with the corresponding EPCIS event. And this is very important because this transaction together with the event will be the way that the winemaker will use to certify that the wine is the one and it is authentic. So once this is recorded on the IOTA distributed ledger, which is the flow number 1, then it comes the moment when the importer receives the wine at his warehouse. And at his warehouse, the wine is received through some kind of door where there is a fixed RFID reader, for instance. A new event is generated for each box, for instance. This event comes through the Zebra Savannah webhook, and it arrives into the product verification service. Of course, the verifier, the importer, could also record that event in the track and trace ledger APIs. But now let's focus on the product verification steps. And once it comes to the product verification service, then there is a query to the track and trace ledger APIs and say, oh, I have received this product. Please give me the identity of the maker, for instance, using the GS1 company prefix. Then the identity of the maker, which is a decentralized identity, could be obtained by the product verification service, resolve the DID, resolve the decentralized identity, and then get in touch with the winemaker, because in the decentralized identity, there is also an endpoint, a service offer. There is declared there a service point offered by the winemaker to check for authenticity. And the product verification service calls the product authenticity service of the winemaker. And then the winemaker says, yes, thank you for sending this request. You can see in this transaction on the distributed ledger that this wine is authentic. Yes, so it provides the transaction to the product verification service. And then the product verification service retrieves the data of the transaction and verifies that the fingerprint on that transaction corresponds to the tag that he has read from the RFID reader from Zebra. And if there is the proper match, if the fingerprints match, and of course, the product verification service will always verify the signature attached to the transaction. It means that the product verification service must verify the authenticity as well of the data in the distributed ledger, so that the originator of that transaction is really the winemaker. And how it's been done? It's been done using the decentralized identity, because in the decentralized identity, there is the public key materials of the winemaker. And that's a very important point. And then the product verification service can verify the authenticity. And if there is any kind of counterfeit, any kind of forging of the tag, because the tag identifier does not match with the one originally made by the winemaker, then in that case, the product verification service will detect that and will generate an alarm. And you can see that this network of trust is built using the distributed ledger, the IOTA Tangle, but also with the help of some APIs that allows you to build this kind of application together with Zebra data services more easily. And that is the beauty of these APIs, that with REST APIs, with JSON format, with EPCIS, you can build these kind of applications in an interoperable way. So that's important. And moreover, the consumer could resolve, could with the digital link, which is an extended barcode standard proposed by GS1, with that digital link, the consumer could also get access to these EPCIS events and also say, oh yes, this is my wine is authentic. So we are covering with the same common data format different interactions between different kind of stakeholders and in different setups, business to business, business to consumer. And of course, these kind of applications, you can imagine that the application used by the consumer could be used not only for wine, but for other goods and in other supply chains. And thanks to data interoperability, this can be done. And this is one of the USPs that we are proposing with this approach. So in here, what would be the data flow? Well, the data flow here, we have print transactions generated by Zebra printers that are recorded at device events. But in this case, we will have extended data like the proof, which this proof is essentially a fingerprint of the tag. And we have the business event. So here we have the commissioning event when the box of bottles of wine is initially added a label. We have the commissioning event. Then we have the storing event when the wine importer receives the box of bottles of wine and are stored in their warehouse. And you can imagine that at this point in time, this EPCIS event will generate it only and only if it can be guaranteed the authenticity. So this event, of course, will not be stored if the importer detects fraud, because if the importer cannot verify the authenticity with the corresponding print transaction, then it would not even store. So it would put in another state or in a different stream channel, etc. And finally, you can see how or what could happen at the selling point. So at the selling point with the consumer, you could generate a different kind of EPCIS event. So the standard is quite flexible, and you can see that all the identifiers, etc., comply with the EPC standard. But as you know, EPC is very extensible, so you can define different, I would say, spaces of identifiers using the same GS1 EPCIS standard. So these are the kind of applications you can build with our approach. But what is our roadmap? Where we are? Well, I have to say that we are working on extending this offer. And the first thing that we are doing together with Zebra Technologies is providing not only, I would say, the REST APIs to work with this, but also some SDKs that would allow you to, for instance, onboard your devices on the supply chains, because this depends a lot on devices, on Zebra devices, and depends a lot on these devices having their proper identity. So one important step is, for instance, onboarding these devices on the supply chain so that those devices can have an identity and it can verify the origin of the events generated by the devices. And this is what is being done with the Zebra IOTA Edge SDK together with other applications for devices for verified credentials as well. So for instance, a transporter when arrives into a warehouse to pick some goods, the transporter could even present a credential that can be verified by the supplier and say, oh yes, you are who you say you are, and now there is this change of custody of the goods, and it can be recorded on the distributed ledger that the change of custody happened and that the proper transporter is authorized, is the one I was expecting, because otherwise I could give the goods to another person or to another organization, or even to the wrong lorry. So these kind of things we envision that in the future would be enabled on the Zebra devices directly with the support of the IOTA distributed ledger. And this is what we are doing. And furthermore, in the future, we also envisage that some of the EPCIS events could be generated automatically from these devices using this SDK. This is work in progress, but a preliminary version is planned to be released and to be available by the end of the year. And next year, we will continue working on this nice offer. So at the moment, when it comes to the track and trace ledger APIs that we have mentioned here, we have them pilot ready and available on the Zebra Savannah, so you can test them at the moment together with the identity part, or all the things, all the applications that we have been discussing so far in this presentation can be made real on a pilot ready state using the current version of the track and trace ledger APIs. You have device event, EPCIS events, identity, even some support for master data. But we are going further. We are enabling as well this HSDK, and we plan next year by Q2 2022 to have a pre-release version of these APIs ready not only to be executed on a sandbox, but also to be executed on your favorite cloud platform or on your favorite on-premise setup, and get all the advantages of using or implementing decentralized supply chains with your partners. Of course, the solution will be evolving and will be incrementing their support. And here we need collaboration, business, integration with customer-specific projects, and we are very open to have partnerships and collaborate with you on making this advance and progress. And what is important as well from this presentation is to get your feedback. We are working intensively with this. This is innovation, but this is as well can give a very big impact to the digitalization of supply chains and to building better supply chains. So it's very important, please, that you can give us the proper feedback. And of course, we are very, very open to it. So the follow-ups, you have additional resources. You can see the authenticity showcase in action. You can see the track and trace ledger APIs at the Zebra website. We have different tutorials for these APIs. This is important because you can follow the tutorials and for free in the Zebra Savannah environment, play with them, use the IOTA distributed ledger, use the EPCIS events. This is also under a Postman collection for your convenience. Also, I would like you to raise the attention about the blog post we recently published about EPCIS 2.0 and how it relates to IOTA. Is very interesting because it summarizes some of the ideas that we have been putting together during this presentation. And of course, please ask any question through this conference. I'm very happy to respond to them. For any kind of business follow-ups, you have the addresses of the people at the IOTA Foundation and Zebra, and in Zebra, when it comes to business development. For any technical question, we already have the IOTAstackexchange.com, but also I'm pretty sure you can do the same questions as well through the Zebra development channels. So thank you very much for attending this presentation, and very happy to respond to your questions. Enjoy the conference. Bye-bye.